Hi everyone, today we're doing question 314 on LeetCode called binary tree vertical order traversal. So given a binary tree, and if we go down with straight lines, we just want to see which nodes will intersect. So in this case, 9 is in its own column, followed by 315, then 20, and finally 7. So it makes sense to use BFS for this. We'll keep track of which column we're in, as well as going down left and right will cause the columns to go -1 or +1 respectively. And that's it. So let's get started. So let's start our queue up. For my queue, I'll keep track of not only the node, but also the column itself. So let's call it the node starts at the root. And the column, which I'll just call level, starts at 0. So once again, every single time we go to the left, it's going to be level -1. Every single time we go to the right, it's level +1. Let's keep track of our result. Let's start our BFS. So we can say while theta length is greater than 0. It's called the current element occur. So how do we keep track of our levels? Well, because we're going to go into negative levels on the left, a array can't keep track of negative indexes. So instead, let's start a map to keep track of where we are and where we're going. And by the end, we'll use the map to iterate into our result. So we can say, if the map doesn't have the level that we're at, let's initialize it as an array. Level, then we just push it into our array. So map.get create a level push. This would be cur.node.val. Cool. Then we'll get the left and right nodes. So if cur.node.left, say q.push. Let's push this object node cur.node.left, and the level, as we talked about before, is just going to be the current level -1. Same thing with the right. Every single time we're going to move right, we're going to add 1 to the level. Cur.level +1. Cool. So now our mapping should have every single level as well as the values. So to put it into our result, the best way is we want to start at our leftmost column and then work our way all the way to the right. So we should actually have a way to keep track of the leftmost and rightmost columns as well. So let's say let min infinity max equals -infinity. And then over here, we can just update them. So min itself and the current level. And the max, the same idea. The max between itself and the current level. So finally, in our iteration, we start at the leftmost column, work all the way to the rightmost column, and we can say result. The first index is going to be at index 0, so that'll be just I minus min, because since we're starting at min, this is literally saying min minus min, which is just 0. It's going to be equal to map.get I. The reason why we get this is because we're using I to iterate through the columns. So we're getting every array from the mapping. Then we just return the result. Cool, let's see if this works. Something didn't work. Why did it not work? Oh, oops, this should be turned on. Not turned on. Works just fine. And oh, if we have an empty tree, so if root, return the empty array. Let's try again. Works just fine. BFS runs through every node at most once inside the tree. So it's going to be O of n, where n is the number of nodes in our binary tree. Cool. So with that, I'll put a link to the question as well as my GitHub down below. And I'll see you guys next time.